So the next chemical property of water is pH. Okay, so this pH, it is used to find out whether the water is acidic or basic. Okay, so in this pH, this P stands for potence. Okay, so from this potence only the potential word is derived, and this H stands for hydrogen ion, that is H plus concentration. Okay, so pH is nothing but it is a measure of potential of hydrogen ion concentration. That is how much hydrogen ion concentration is present in a particular liquid. So that gives the pH value of that. So write down pH is the measure. pH is the measure of potential of hydrogen ion concentration. Okay, one more point, you write it down. Whatever the water treatment we are studying, okay, so the water treatment is sensitive to pH. So water treatment is pH sensitive. That means, what do you mean by sensitive? That means it depends on pH. Dependent on pH. Okay, so some of the processes can be reduced if we control the pH in the initial stage. That will be seeing in the subsequent videos. Okay, so right now we are only studying the quality of water. So main parameters will be seen, the processes and how each parameter affects one process, that we'll see in the next unit. Okay, so for what purpose it is used? pH. So pH is used to find out nature of water. Nature of water is determined by using pH. Now how to measure this pH? So this pH is measured by an instrument called as potentiometer. Okay, so now we will see what is the formula for pH. So for that we will have to take one equation. So A plus B, it gives C plus D. If this is the standard equation, then from chemistry the ionization constant K is equal to product of concentration of products by product of concentration of reactants. Okay, so this box stands for concentration. Okay, so it stands for concentration of the particular product or reactant. So this is the formula for ionization constant. Now if we use this formula for H2O, that means H2O gives H plus and O minus. So apply this formula. So ionization constant K, it is equal to concentration of H plus, that is product, concentration of OH minus divided by concentration of H2O. Now for pure water, at for pure water at 25 degrees centigrade, concentration of H2O is equal to 1. Okay, so if we use this condition of pure water at 25 degrees centigrade, concentration of H2O will be 1. So this 1 is in moles per liter. Okay, so the unit of concentration is moles per liter. Now substitute here. So this K, it is equal to, this K is equal to, okay, one more thing. At this temperature 25 degrees centigrade and for pure water, there is one more value that we have to take, that is the value of ionization constant. So this ionization constant is 10 to the power minus 14. Now substitute everything. So this will be 10 to the power minus 14 is equal to concentration of H plus into concentration of OH minus. So concentration of H plus into concentration of OH minus is equal to 10 to the power minus 14. Now applying log on both sides, apply log on both sides. So we'll get log of H plus into OH minus is equal to log of 10 to the power minus 14. So log AB is equal to log A plus log B. So log of H plus plus log of OH minus is equal to, this will be minus 14. Okay, basic logarithmic formulas. Now multiply by minus. So minus log of H plus minus log of OH minus is equal to minus into minus plus is equal to 14. So this term which you are seeing here, minus log of H plus, this is called as pH. Okay, and the second term here, that is minus log of OH minus, this is called as pOH. Okay, that is potential of hydrogen ions. Now, so from here, what is the formula for pH? So pH is equal to minus log of H plus. Okay, minus log of H plus. And what is the formula for pOH? Minus log of OH minus. So these are the formulas. One more relation you can see here. If we write this in terms of pH and pOH, we can write pH plus pOH is equal to 14. That is pH plus pOH is equal to 14. This H plus concentration, that is concentration of hydrogen ion, this is expressed in moles per liter. When we'll solve the problems, we'll see. So right now just write it down. So this is all about the pH formula and the derivation of pH and the relation between pH and pOH. Now if we draw the scale for pH, then it is 0 to 14. So 0 is called as acidic and this is basic. This is also called as basic or alkaline. And this is the average value. Now for drinking water, what is the specific range? So for drinking water, the pH should be 7 to 8.5. So from here to 8.5. So 7 to 8.5. This should be the range for drinking water. So we'll write it down on the first page only. So the range of drinking water it is 7 to 8.5. So very small formulas are present in this pH, and the questions which are asked in the examinations like GATE or ESE, the models of that questions are also same. Okay, so the models are repeated. So there are few models, you just practice them with this formula and you will be good to go for the exam. Okay, so that's it about pH.